Okay, so the nice part of today is we don't really have to go into too many new things. We're just going to figure out what appropriate sample size we should want to take for these confidence intervals. But the other thing is we're going to try to review everything and try to put everything together that we've learned. Here's a normal problem where they want us to make a confidence interval. And we're going to do a couple things. Like first thing that we're going to do is we're going to plan. And in the planning stage, we just need to see if the major requirements are met. Is it random? Is it normal? And is it independent? If it's not those three things, we're just going to stop. Can't make a confidence interval. The next thing is if that's true, we're going to calculate the confidence interval based on the data they gave me. And at the end, we're going to interpret. So we're going to try to do those three steps with this problem. So the first thing it says, the Gallup survey asked a random sample, sweet, one of the requirements is met, of 439 U.S. teens on whether they thought people should wait to have sex until marriage. Of the sample, 246 said yes, and they said construct a confidence interval. So let's check to see if this thing's normal. We check that by doing the NP is greater than 10, or N times 1 minus P is greater than 10. Both things need to be true. So let's just check that real quick. So we have 246 divided by 439, so about 56%, times that by my sample size, which was 439, easily big enough, and then the other side would be like 44%, so 0.44 times 439. Good, they're both above 10, so we're good. Checks out, checks out. So now we can actually calculate a confidence interval. From here on out, I would not calculate these things by hand. That takes a long time, and we have calculators. So I'd go to stats, go over to test, go down to, we are dealing with proportions, so 1 proportion z interval. We have, 246 successes out of 439 people, and we want a confidence interval of 0.95. So we'll just say calculate. So then our confidence interval would be between 51% and 61%. I'm fine if you round these. You don't need to be super precise. Now we'll interpret. So I would say, like, our interpretation of this is that we'd say something along these lines. We are 95% confident, and I want to use the word confident instead of like percent chance, that the true number, or the true percentage sorry, it's hard to write, of teens that believe you should wait for marriage to have sex is between this interval. And that's how we'd go about it. Again, use words like confident. You want to bring something like in that tells them what they're dealing with, which in this problem, that's what we were dealing with. So that's kind of how we want to interpret at the very, very end. And so we know that, like, it's probably like in the United States around 51 to 60%. It's probably true. We're pretty confident that that's where it's at. And we're going to now move into like what a good sample size is. So sometimes you have to decide on a sample size. Okay, so for the second part of the problem, what we want to find is we want to find the number or the sample size we need to get this margin of error. Okay, given that this is the percent that we found for the sample. So the first thing that we want to do is we want to think about how we find margin of error. And your margin of error is this part over here, which before we said that that's z star times your standard deviation, which for this would be p times 1 minus p over n. And we're hoping that our margin of error would be 3%. So we're wanting this to be 3%, or if we want to write 3% as we need to, 0.03. So that's what we're trying to make that to be. Let's solve this. So our z star is at 95%, and a good one to know from the tables, if we went back to the tables, 95% is 1.96. Our p that we found was 0.8, or 80%. So our 1 minus p would be 0.2. And that's going to be all over n. And we want that to be 0.03. The nice part is now we just get to do some algebra. And it's not even that bad of algebra. We'll move this to the other side. That will give us about 0.015. We'll square this to get rid of the square root. Bring up that calculator again. So that gives me a really small number. I'm just going to leave that because I don't want to write that whole thing out. And then what we have to do is, this is kind of a proportion. This would really be over 1. So what I would just do is I would cross multiply and then divide. So really what we're going to do is 0.8 times 0.2 divided by 0.015 to the second. So let's do that on this calculator because it's a little bit easier to do it here. So 0.8 times 0.2 divided by 0.015 squared. So about 711. That's what we would want to make m. So the big thing, if you have to do this type of problem, is it's just kind of algebra. You just use what you know about how you find your error. You just plug all the numbers in and then solve for n. So try the different problems today. If you get stuck, please ask questions.